Humanity is absolutely obsessed with these plants. Suburban dads devote their weekends to them, endless ads promise to get their stains out. A third of residential water in the US, 9 billion gallons a day, is used to keep them looking fresh and green. But this obsession stacks up. These are the most important plants in human history. These are grasses.
Hey, I'm Tasha the Amazon, and you're watching Animalogic. Today we're talking about a family of plants you literally owe your life to. Wheat, corn, rice, barley, oats, rye. Almost everything that keeps humanity fueled up is a species of grass.
Rice and wheat alone provide the planet with around 40% of its daily dietary energy, with corn adding another 5%. Even the food we give our livestock to provide us with dairy and meat are mostly grasses. And grass is everywhere, covering about 25% of the Earth's land surface.
In addition to being a staple in our diets, grasses also create a huge amount of the oxygen we breathe. They're actually way more efficient at filtering out carbon dioxide and producing oxygen than trees. A lawn the size of a basketball court will produce enough oxygen for 8 people. To get the same amount, you'd need about 64 trees.
There are over 10,000 members of the grass family, known as Poaceae. Although all part of the same family, the individual members of the grass clan definitely all have their own vibes. They range in size from one of the smallest, Mabora minima, which can be just 2 centimeters tall, to the largest grass family member, bamboo, which can grow to be up to 40 meters and measure 30 centimeters across.
They also range wildly in flavor, from the distinctly grassy notes of wheatgrass to the addictively sweet kick of sugarcane. Although they differ so greatly, almost all grasses share a set of common characteristics.
The roots of grasses are fine and fibrous, unlike the taproots of other species. The stems, called culms, are usually hollow and woody, and their leaves are narrow with parallel veins, where the leaves attached to the culms are usually bulges called nodes, which are solid. Grasses also have small and inconspicuous flowers, which makes sense because they're actually a flowering plant.
While they're usually freestanding and terrestrial, there are outliers in this large family. Arthrostylidium, for example, is a genus of climbing bamboo, and wild rice is an example of an aquatic grass variety.
And grasses are tough. Unlike most other plants, grasses have even conquered Antarctica. Conditions in Antarctica are absolutely brutal. It's freezing cold, wildly windy, and despite the snow and ice everywhere, because of the sub-zero temperatures, it's dry as a bone.
With summer lasting just a few days to a couple months, depending on the location, life in Antarctica is tough for everyone, but especially plants, which require the sun for photosynthesis.
Most Antarctic plants are hardy lichens, mosses, and liverworts. There is one species of grass, however, that has populated Antarctica, Deschampsia antarctica, commonly called Antarctic hairgrass. This is one of only 2 species of flowering plants that grow here. Antarctic hairgrass grows mostly in the maritime region near the coast and thrives where penguins and other animals hang out, soaking up the nutrients from their poop. Their seeds are dispersed by birds that feed on them and then poop them out again elsewhere.
The ability to thrive in Antarctica goes to show that grasses have evolved to be survivors. These plants can tough out anything Mother Nature throws at them, from frost to drought to heavy grazing and even fire.
Part of the reason they can bounce back is that the majority of the plant is actually in the roots, safely underground. The large root systems allow the grasses to tap into underground water sources, ensuring they can survive a drought. And because even the buds are underground, if a fire burns the exposed grass or a sheep chows down on an entire plant, more culms and leaves will shoot up like nothing happened. In extreme temperatures, either hot or cold, grasses will go into a period of dormancy. The leaves and stems will turn brown and dry up, only to pop back up looking fresh and green once the weather turns around again.
The evolution of grasses has been a hotly debated topic in paleobotany for as long as the concept of evolution itself has been debated.
For a good long while, based on the fossil record, it was believed that grasses only evolved around 50 million years ago, meaning that dinosaurs and grass never existed at the same time. In 2005, however, the debate heated up when a swath of different grass species were found in dino-coprolites, otherwise known as fossilized poops.
These poops were from the late Cretaceous period, which ended with the great extinction of the dinosaurs 66 million years ago. The diversity of the species found in these poops suggested that grasses had already been evolving long before these poops were plopped.
Other clues about the evolution of grasses come from the species we have all around us today. By studying the genomes of these grasses and taking mutation rates into account, we can estimate how long ago this family started to diversify.
Some researchers believe now that grasses started evolving as far back as 82 million years ago, deep in the Cretaceous period. This might sound like a lot, but in relation to the entire history of planet Earth, grasses were basically born yesterday.
Being around 82 million years ago means that grasses played an important role in the angiosperm terrestrial revolution, an explosion of diversity of land plants and animals that took place 100 to 50 million years ago. This was a time of big innovation for flowering plants, with their flowers evolving to be more efficient and co-evolving with creatures like pollinators and herbivores.
They also amped up their powers of photosynthesis, their adaptability, and their ability to modify habitats. And modify they did, since now over a quarter of the planet's land surface is covered by grasses.
Entirely new grass-based ecosystems began developing in the form of grasslands 20 to 30 million years ago. This was during the Oligocene, in which the whole planet experienced cooling and drying, with major changes to precipitation. These environmental changes provided the perfect conditions for the tropical forest plants of the past to be replaced with the cool, dry-loving species that form the grasslands and savannas we see today.
And these new grassy habitats drove the evolution of all kinds of animal species, including us humans. Recent studies have shown that humans can thank the spread of grasslands for our flexible diets, our complex social structures, our ability to walk and run on two legs, and even our big chunky brains.
As hominins, our early ancestors, diverged from chimps 6 or 7 million years ago, the vegetation in East Africa was shifting from forests to grasslands dotted with patches of woodland. These wide open spaces forced our ancestors to come down from the trees and learn to move quickly across these open spaces.
This new environment also drove them to stand tall to see above the high grasses and to work together to find food and avoid predators.
Over time, our ancestors evolved to thrive and travel over vast distances across savannas. It was adapting to these new grasslands that allowed our early ancestors to evolve into the humans we are today.
So after all that, I guess it makes sense that we're totally obsessed with grasses. We have them to thank for basically everything. You'll never look at your bowl of noodles or rice the same again. So what should we talk about next? Let me know in the comments, and don't forget to subscribe for new episodes every week. Bye! Hello! Shall I do it again? Shall I go again? Should I go again? I'll do that again. Holy grail! I'll do it again. Here we go. Survivors. Your ass is grass. Smoke grass. What other things do people say about grass? Grass is always greener. The Grassy High is a show about the grass. The more you know, the more you know.